The ancient Sanskrit epic of the Tripura describes three massive floating cities that navigated the heavens. These cities belong to the Asuras, who are credited with their construction and sophisticated operation. The texts describe a specific material composition for each structure, one of iron, one of silver, and one of gold, each equipped with its own specialized defenses. This narrative addresses a classic aerospace problem. To maintain control over a planet, a civilization must first dominate the space immediately surrounding it. When analyzed through the lens of modern engineering, the Tripura legend appears to map directly to theoretical models for orbital defense and kinetic bombardment. To test this hypothesis, we have to look past the folklore and evaluate the text using the principles of material science and orbital mechanics. The stage for this system is the vacuum surrounding Earth, an environment that dictates strict physical constraints on any large-scale structure. The legend organizes these three massive cities into a tiered system, with each station occupying a different altitude. The City of Iron is linked to the lowest level, situated closest to the planet's surface. The Silver City occupies the middle tier, described as being in the sky. The Golden City sits at the highest level, referred to in the texts as heaven. These material designations suggest that the survival of each city depended on how its hull responded to the specific hazards present at its assigned altitude. Operating in a vacuum exposes a structure to constant solar radiation, atomic oxygen erosion, and high-velocity micrometeorite impacts. The Gold City was positioned at the highest altitude, where thermal management is the primary engineering hurdle. This diagram shows how gold functions. It reflects infrared radiation, essential for protecting systems from solar heat. This is why gold is used on the James Webb Telescope and astronaut visors. It is a functional requirement for high-altitude survival. In contrast, the Iron City was positioned at a much lower altitude, closer to the atmosphere. In low Earth orbit, atomic oxygen actively erodes surfaces. Dense iron alloys provide the mass and durability needed to maintain integrity in this aggressive environment. Silver and iron alloys further provide the high-density shielding required to protect against electromagnetic interference in the intermediate bands. The material choices in the text align with the actual metallurgical needs of three distinct orbital regimes: LEO, MEO, and geostationary orbit. The legend claims these cities were impenetrable, except for a single moment when they aligned perfectly in a single row. This event reportedly occurred once every 1,000 years, describing a complex problem in orbital phasing. Kepler's third law states the period of an orbit is determined by altitude. Therefore, the three cities would be moving at vastly different speeds. The velocity disparity between low, middle, and high orbits means the stations almost never occupy the same geometric axis. Predicting the exact second these three trajectories intersect in a linear syzygy is a task requiring modern supercomputing. This alignment creates a brief, calculated window of vulnerability. It is the only moment where a single trajectory could theoretically pass through all three targets at once. The result is a single geometric axis, a fleeting target created by the intersection of three distinct orbital speeds. What the legend describes as a 1,000-year miracle is, in reality, a targeting problem of immense mathematical complexity. At the precise moment of alignment, the deity Shiva is said to have destroyed all three cities with a single weapon, the Pashupatastra. This weapon is described not as a blast, but as a single specialized arrow. In a vacuum, standard explosives are inefficient. Without an atmosphere, there is no medium to carry a shockwave and no oxygen to sustain a traditional explosion. This makes kinetic energy the most effective way to destroy a target in space, a concept modern engineers call rods from God. This chart illustrates the physics. Energy increases with the square of its velocity, meaning a mass at orbital speeds carries more destructive power than a chemical warhead. By launching a dense mass on an intersection trajectory, the projectile uses pure motion for its effect. Upon impact, the sheer kinetic energy instantly vaporizes the target, bypassing the need for an internal explosive payload. Shiva's single arrow is a precise description of a modern kinetic kill vehicle. It is a weapon designed to overcome advanced metallurgical shielding through the application of pure physics. When the projectile enters the calculated axis, the alignment allows it to strike all three tiered stations in rapid succession. These facts demonstrate that the Tripura epic is built upon a sophisticated understanding of altitude-specific materials, orbital phasing, and kinetic physics. The legend is a technical outline of a modular orbital habitat system and the specialized architecture required to destroy it.